Hello everyone. Today I am gonna tell you about Introduction to Data Science. What does basically data science means? If we go by definition, data science is an interdisciplinary field which uses scientific methods and algorithms to extract knowledge for business understanding. And it contains some properties such as data mining, data cleaning, data exploration, feature engineering, predictive modeling, and virtualization. So if we see data mining is the finding errors, correlations, patterns with the data set related to our analysis. Now we come to data cleaning. In data cleaning, we remove the unwanted data from the data set. Now data exploration. Based upon the problems making hypothesis. We explore the data and then we extract the problems and then make the hypothesis. Now in feature engineering, selecting good features which are helpful in study to make some meaningful insight. Now predictive modeling. To take out predictions from data using algorithms is known as predictive modeling. Virtualization. Analyzing the data visually through graphs, algorithms, also using to make the model from the data. So guys, basically data science or data-driven science is all about asking the right question and exploring the data, modeling the data using various algorithms and then communicating and visualizing the data. Now we come to the basic difference between business intelligence and data science. In business intelligence, we deal with structured data, whereas in data science, we deal with structured and unstructured data both. Main focus in business intelligence is on present and past data, whereas in data science, we focus on future predictions by data analysis. Some of the methods and tools which are used in business intelligence are analytical tools, statistical, and visualization, whereas in data science, we use everything such as statistical tools, data visualization, machine learning, deep learning, etc. There are some prerequisites for data science. Knowledge about machine learning, mathematical modeling, background about computer programming, statistical analysis, knowledge about database. These skills are required for a person to be in data science field. Now, some of the skills, tools which are used in data science, basically for data analysis, are Python, RapidMiner, Excel, R. Now in data warehousing, we use SQL, Hadoop, AWS, Apache, Spark. Now in machine learning, we use Python, algebra, statistics. In data visualization, we use Python libraries, Jupyter, Tableau, R. So now we come to why there was need for data science. Because of the revolution of technology, where data used to flow, it was unstructured, then it used to store, then there was lack of predictive analysis, lack of scientific insights, then decision was to be made, predictions were to be made, then pattern discovery was done, and then we came to a science which is known as data science. This is a series of patterns in which the world of innovations work. So till now we were telling about the evolution of data. Now we come to the another unit which deals about big data. So what do we mean by big data? So big data is a term for collection of data sets so large and complex that it becomes difficult to process using on-hand database systems. There are 5 V's of big data. First one is volume. In this, we deal with large volume of data which is itself enormous in size, and data is massive amount of data. The size and amount of data that companies manage and analyze is too much. So we are not able to store in SSDs, we then store in cloud storage. The second V, which is value. The bulk of data having no value is of no good to the company unless you turn it into something very useful. Data is of no use or importance, but it needs to be converted into something valuable to extract some information and perform some analysis by the company to have the meaningful insight. So we derive this V. Now we come to third, that is variety. Variety is the availability of data from new sources both inside and outside an enterprise. It can be structured, semi-structured and unstructured. Basically, structured data is organized data and data made into tables arranged in a proper length, and there is a proper format of data. In semi-structured, the data is semi-organized, which means that it is generally a form of data that does not conform to the formal structure, such as log files are example of semi-structured data. Now we come to unstructured data. This data refers to the unorganized data. It generally refers to a data that does not fit neatly into any relational database and has many outliers. Some of the examples are texts, pictures, videos. The diverse range of these data types includes unstructured, semi-structured and raw data. Now we come to fourth V, that is velocity. The amount of the speed at which the data is increasing day by day at every second is known as velocity of data. In big data, velocity, data flows in from sources like machines, networks, social media, mobile phones. And there is continuous and massive flow of data where it determines the potential of data and how fast the data is being generated and processed to meet the demands. That is, the sampling data can help in dealing with this issue like velocity. Now we come to veracity. It refers to inconsistencies and uncertainty in data, which is available data can sometimes get messy and quality and accuracy are difficult to control. Big data is also variable because of magnitude of data dimension resulting from multiple disparate data types and sources. His example is data in bulk could create confusion, whereas less data could convey half or incomplete information. Now, how big data was evolved? Due to the evolution of technology, IoT, that is smart devices, social media, personal details, most important data generated in data evaluation. Data evaluated from other resources like purchase pattern of the customers through shopping platforms are also an opportunity of big data. Now, in big data analysis, we have four types of things. First one is cost reduction. We can perform analysis and we can predict the cost of any product. Now, second is faster and better decision making. It helps a company to make a better decision while manufacturing product. Now, third is improved services or products. Through big data analysis, we improve our services and read what the customer needs. And also, fourth one is next generation products. New innovation, new products which can be used by people and will be liked by the people can be invented and can be made, which will gain lot of popularity in the market. Now we come to another topic, that is sources of data. Primary data and secondary data. There are two types of data. In primary data, the data is raw, original and extracted directly from the official sources, which is known as primary data. This type of data is either collected directly by performing techniques such as questionnaires, interviews, surveys, Google form, and the data collected must be according to the demand and requirement of the target audience on which the analysis is basically going to be performed. Otherwise, it will be a burden in data processing. In secondary data, the data which has already been collected and reused again for some valid purpose. This type of data is previously recorded from primary data, and it basically has many resources named internal source and external source. Some of the sources are flat files. What are flat files? Flat files is defined as data files in text form or binary form with a structure that can easily be extracted by data mining algorithms, and they can be represented by data dictionary. example CSV file, and its application is used in data warehousing to store data, used in carrying data to and from server. Second is relational database. A relational database is defined as the collection of data organized in tables with rows and columns. And its physical schema in relational database is a schema which defines the structure of tables. Its application can be in data mining or RALP model. Now the third is data warehouse. A data warehouse is defined as the collection of data that is interacted from multiple resources that can be queries and decision making. Now its application can be in data mining and business decision making. Fourth one is transactional databases. These type of databases deal with time spans, dates to represent transactions in databases. This type of database has the capability to roll back or undo its operation when a transaction was not completed or not committed, such as we see when any bank transaction is there in our net banking or other resources. Though we use these type of databases in banking distributed systems. Now fifth one is multimedia database. The multimedia database basically consists, as its name is, audio, video, images and text media. There can be stored in object oriented databases. Now sixth one is biological data. Biological data, as its name suggests, is about a person, organized body of persistent data usually associated with computerized software designed to update, query and retrieve the components of data stored with the system related to any particular disease or human, etc. The seventh one is time series data. Time series data contains stock exchange data and it's very useful in this data. It basically stores the user logged activities and handles array of numbers indexed by time, date. It requires the real-time analysis and it has a very good application in InfluxDB and Graphite. Now we come to third unit, that is machine learning. Machine learning is the scientific study of algorithms and statistical models to perform a task using inference rather than instructions. In this, data, model and prediction is the machine learning flow which can be seen. It is used in sales forecasting for predicting sales of a particular product. Fraud analysis, fraud detection in banking transactions can be done using machine learning. Machine translation. It can convert a text or audio to different languages of our choice. Recommender systems. Use of ML algorithms can be used to suggest us products, TV series, such as based upon our interest. Basically, it contains three types: supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, the basic meaning of is label features. It is related to an example such as coins of different types are classified on the basis of its features. That is, a supervised learning is being given on this data model. Now in unsupervised learning, it's based upon performance but not on label features. Such as in a cricket match, we measure the performance of the players, not the features of the players. Now we come to reinforcement learning. In reinforcement learning means reorganizing by giving feedback and learning by the system, such as self-driven cars. In this data model, they learn by seeing and presenting on-road activities, and then they implement those learnings in their data model. Now, in machine learning is a subset of AI, which is a broad branch of computer science for building machines that can do human tasks. Deep learning itself is a subdomain of machine learning to understand where these ideas fit together and in the field. Basically, the subset AI is a subset of ML, ML is a subset of deep learning. Now we come to ML process. In this, first one is business problem, that is converting the business problem to ML problem. Second one is problem formulation, that is collecting the label and giving it to the ML algorithm. Third one is evaluating data, how we evaluate the data and process in the algorithm. Fourth one is feature engineering, how the data is being amalgamated and decision is being made by the algorithm. Fourth one is selecting and training the model. In this we choose which model is to be taken and we train it accordingly. Now other one is evaluate model. We evaluate the model. Has the model meet our requirements or not? Has it meet the business goal which we wanted, an objective which we wanted to reach through that model? That is it overfitting or underfitting, in which the overfitting when the model performs well on trained data but it does not perform well on evaluating data, it is known as overfitting. Whereas in underfitting, the model is underfitting under training data as it performs poorly on training data, it cannot capture the relationship between the input and examples. Artificial intelligence performs human tasks. Machine learning, training models to make predictions. Deep learning is basically contained of neural networks. The technology and economic advancements have made machine learning more accessible to individual organizations and firms. Now, the fourth unit is first steps in big data, that is distributing data storage and processing with frameworks, which relates to SQL and NoSQL. In SQL is a standard language for storing, manipulating and retrieving in databases. SQL may teach us MySQL, SQL Server, MyAccess, Oracle, Informix and etc. databases. In NoSQL stands for non-SQL or non-relational database, which provides a mechanism for storing and retrieval of data that is modeled in means other than tabular relations used in relational databases. Such databases existed since late 1960s, but the name NoSQL was only coined in early 21st century, triggered by needs of web companies. Now, it is used in increasing due to big data and real-time web applications. NoSQL systems are also sometimes called not only SQL to emphasize that they may support SQL-like query or sit alongside SQL databases. Now there was a discussion upon which is better, NoSQL or RDBMS. In today's world, the kind of data being generated by users is not only vast but heterogeneous and distinctive in nature. In such a landscape, using traditional RDBMS is not feasible. So we use NoSQL, which is better suited for handling the 6 parameters of big data, as they are flexible in nature, that is can be used in any kind of data, whether structured, unstructured or semi-structured, scalable with growing data amidst a server system. Handling of NoSQL frameworks are sturdy, not requiring any specific schema. If data nodes aren't related, there is no fixed number of attributes that are needed to be filled up, unlike traditional RDBMS. Cheaper to operate, the servers of NoSQL databases can be held in cheaper hardware machines, as most of the backup data will be on cloud servers. Now, the fifth one is stored actually in an unquantifiable manner, that is in petabytes and terabytes. So, as the discussion is, we came to a conclusion that RDBMS and NoSQL are both distinguishable but both as important as each other. The specific requirements and data being tended to decides which one is to be used by the organization according to their need. So now we come to the fifth unit, that is ethics and data science. There are some ethics and moral which are to be maintained for being in data science. So first one is the 5 C's, the 5 framing guidelines to help you think about building the data products. First one is consent. You can't establish trust between the people who are providing you the data and the people who are using it without agreement about what data is being collected and how that data will be used. Agreement starts with obtaining consent to collect and use data. Unfortunately, these agreements between the service users and the service itself are binary and lack clarity. In business, when contracts are being negotiated between two parties, these are multiple iterations before the contract is settled. But when a user is agreed to a contract with a data service, you can't either accept the terms or you don't get access to it. It's not negotiable. The second C is clarity. There is no clarity about our data. Clarity is closely related to consent, but you can't really consent to anything unless you are told clearly what you are concerned to. Users must have the clarity about what data they are providing, what is going to be done with that data, and any downstream consequences of how that data can be used and will be used in the forthcoming future. The third one is consistency and trust. Trust requires consistency over time. You can't trust someone who is unpredictable. They may have the best interactions, but they may not honor those intentions when you need them to, or they may interrupt their intentions in a strange and unpredictable way. And once broken, rebuilding trust may take a long time. Restoring trust requires a prolonged period of consistent behavior. Whereas inconsistency and therefore trust can be broken either explicitly or implicitly. An organization that exposes user data can do so unintentionally or intentionally. In past years, we have seen many security incidents in which customer data was stolen by either Yahoo, Target, local hospitals, government data brokers, which are again the replica of consistency and trust. The fourth one is control and transparency. Once we have given our data to a service, we must able to understand what is going to happen with our data. Can we control how our data will be used by services? For example, Instagram asks us for a political views, relational views, gender preference. So we give it. And after that, what often users have no effective control over how their data will be used. These are given either all or nothing choices for the set of options they make controlling, overwhelming and confusing. A major part of this shit in data privacy rides in moving to give users great control of their data. Now the fifth one is about all, that is consequences of all these things. Data products are designed to add value for a particular user or system. As these products increase, they have a broader societal implications. It is essential to ask whether the data that is being collected could cause harm to an individual or a group. We continue to hear about unforeseen consequences and the unknown about using the data and combining datasets. Risk can never be eliminated completely, but it can be lightened. However, many unforeseen consequences and unknowns could unforeseen and known if the people had tried. All too often, unknowns are unknown because we do not want to know and we don't give it appropriate importance, which is much needed in this upcoming society, as the implementation of 5 C's can improve our lives in many ways, from the mundane to the amazing. Good movie recommendations aren't a bad thing, but we should consolidate medical data from patients around the world. We could make significant progress on treating diseases like cancer, liver cancer, but we won't get either better movie recommendations or better cancer treatments if we can't ensure that 5 C's are implemented effectively. We won't get either if we can't treat others' data as carefully as we have treat our own. So, in short, the 5 C's need to be part of every organization's culture. Product and design reviews should go over 5 C's regularly. They should consider developing a checklist before releasing a project to the public. All too often, we need to think product as minimal viable products. While that's a constructive approach for developing and testing new ideas, even MVPs must address 5 C's. The same is true for well-established products. That is, new techniques may have been developed that could result in harm in unforeseen ways. In short, it also talks about taking the responsibility for the products that are built. The 5 C's are a mechanism to foster dialogue to ensure the products do no harm. So now we discuss what is morality and ethics. Morality is more general and perspective based upon customs and traditions. Ethics are specific and descriptive. It is critical reflection on morals. Whereas in morality, more concerned with the results of wrong action when done. In ethics, we are more concerned with the results of right action when not done. Thus, in morality, thrust is on judgment and punishment in the name of God or by the laws made by the society. Whereas in ethics, thrust is on influence, education, training that codes, guidelines and correction being in society. In morality, there is, in case of conflict between two moralities, is given top priority because the damage is more and it is more common and basic. Whereas in ethics, less serious, hence second priority only because it's less common but irrelevant today's generation because of complex interactions in the modern society. Its morality example can be character flaw, corruption, extortion and crime, whereas ethics example can be notions or beliefs about manners, taste, customs, how we are in society. There are some moral dilemmas. The basic definition of dilemmas are situations in which moral reasons come into conflict or in which the application of moral values are problems and one is not clear of the immediate choice or solution of these problems. Moral reasons could be rights, duties, goods or obligations. These situations do not mean that things had gone wrong, but they indicate the presence of moral complexity. This makes the decision making complex. Thus, there are some difficulties in arriving to the solution to the problem in dilemma. Thank you. I hope the talk was informative and you must have gathered some insights about the data science. That what is basically data science, what are the different types of things, what there are some ethics which will be required in being known of the data science. Thank you.